I'm Marco Bungart. I'm a software engineer at Console, and we are going to talk about GraalVM today. Stated in a different way, we are talking about my socks or what's standing on them. Hands up, who has experience with GraalVM? Okay. Who is using GraalVM somewhat in production? Ah, that's awesome. What we are going to talk about today is a little bit of what is GraalVM, why do you want to use GraalVM, and when should you use it. There are use cases when you should use it, there are use cases where you should not necessarily use it, and please keep in mind GraalVM as is in version 19.2.1 I think, so it's stable. But I also show components that still are in alpha or pre-release. Yeah? So some features might change, some features might completely go away, and please don't use these features in production, they are still pre-release. Little safe harbor statement, I'm not from Oracle, Console doesn't work for Oracle. What I'm presenting are my opinions, the things that I found out about GraalVM, and we are not responsible for what you are doing with the information. So, I think we had a talk today about the JDK jungle out there. And the first question is, why do we need another JVM? We have so many already. Well, Graal offers some benefits we don't have with other JVMs. First off, we have an Extensible Polyglot Jvm. That means we can take the polyglot functionality and extend it to languages that are not yet implemented, or even our own language. We'll take a short look how it's done on a high level. I will not go into detail how to implement them. The second point is we have actually the capability of compiling our Java program into a native binary file. Yeah. When you think back, one of the big features of Java was the bytecode representation and being independent of the machine you're running on. With this feature, looking at the cloud-native approach, we get some interesting benefits, and we'll look at this at the end, on the end of the talk. And when you're using the native image, we have a much lower memory overhead. Normally, when you're running a Spring Boot service, you consume about 200 to 500 MB. You can reduce this significantly by using GraalVM. Yeah. So, why do you want to use GraalVM? Well, we have a polyglot, and maybe for the problem you are trying to solve, the language you're using already is not the best tool to use. So maybe you want to switch to a different tool. The second point is GraalVM is fully compatible with the OpenJDK and Oracle JDK. So even if you don't want to use polyglot capabilities, you can use GraalVM as a drop-in replacement and get some benefit, some performance benefit out of it. Not in terms of memory, but in terms of execution time. We will take a short look at this in the middle of the talk. And when do you want to use GraalVM? Well, as I said, when you already have polyglot project, why not switch to GraalVM? You have a native interoperability between the language you're already using. Plus, when you containerize your application in connection with the native image, you get interesting effects and very interesting images. We'll see that at the end of the talk. So let's look at the high level of architecture in GraalVM. The concept is that you have at the top languages that are supported by GraalVM. As I said before, you can extend this by other languages yourself. And at the bottom, you have different runtimes for executing these languages. And GraalVM sits in the middle. This means everything from the languages goes through GraalVM is more or less normalized for running on the JVM. and you can use your execution times as you know them for Node.js. You can use Node. For JavaScript you can use JS, and for Python you can use Python. And Graal handles the rest. A little bit more detailed, GraalVM is layered in a certain way. The downmost layer you should know already. That's what the normal Oracle JDK already provides. On this layer sits the compiler interface. It's a relatively new interface, part also of the OpenJDK. On top of that, you have the Graal compiler, and this is somewhat special. The Graal compiler has certain optimizations compared to the OpenJDK. In particular, they say they optimized streaming and stream operations. You'll see that in one of the benchmarks I wrote. Up on the Graal compiler, you have the Truffle framework. The Truffle framework is the reason you can extend languages. So Truffle provides you the ability to write some code to transform any language into bytecode, and this is important. When you run Python or JavaScript, Ruby, you're not running in your quote-unquote native environment, but this code gets compiled into bytecode, is then executed on the JVM, and through this mechanism you get all the benefits from the JVM. Mainly, you get hot compilation. Okay? And now the kicker. On top of Truffle is sitting Sulong, and Sulong allows it to run any language that goes through LLVM. Hands up, who knows what LLVM is? Okay, some people. LLVM is part of some C compilers, as well as C++ and Go, and can emit something called bitcode. It's an intermediate representation for C and C++ programs, somewhat similar to bytecode. But through Sulong, you can run everything running through LLVM also on GraalVM, which means on a hotspot Java virtual machine. Any questions so far? If there are any questions, or if I'm talking too fast, too slow, please let me know. Just interrupt me, raise your hand. If I don't react, just raise your voice and say that's going too fast. So when we take a look at what you get when you install GraalVM, can you read that? Yeah? Good. I have installed mine under opt GraalVM CE 19201 bin. When you look into this directory, you see a lot of stuff that's already familiar. You see your Java, Java-C, Java-Doc, Java-H, JCMD. But what you also see are things like JS, Python. You have a Ruby runtime or an R runtime, so you not only get your JVM, but also runtimes for all those languages supported. This is the way how you can compile your guest languages into Java bytecode. Those are the interpreters that are running when you try to execute a JavaScript program through GraalVM, and the compilation to bytecode is done in the background. You just give it some flags, we will see later how it's done, and it gets compiled to bytecode and runs on the Java VM. GraalVM is released in two versions. The one version is the community version. It's open source and free, and you don't have to pay anything for it. But also you don't have guarantees. Some features are missing. I think in-flight recording is not there. On the other hand, you have it as a product from Oracle. So you have a licensing model, you have support, you have some early access features, some performance features that are missing from the community edition. And also I think it's available for free when you're running in the Oracle Cloud. Plus, there's a free tier in the Oracle Cloud, so in some way you can use it for free when you're using a free tier in the Oracle Cloud. Any questions so far? Good. So what are the actual benefits when you are running with GraalVM? The first thing is, as I said already, programming languages, just like patterns or certain programming styles, are tools. There's an old saying, if you have a hammer, everything looks like a nail. Don't do that. If you have a different language that is already doing very well what you're trying to do, why not switch to a different language for this task? If you're trying to compute some matrices, maybe switch to R. It's designed to do that stuff. Yeah? So GraalVM gives you the flexibility to switch languages at will, to use languages as a tool, not as a given or set. Next point is we get some performance benefits when you're using GraalVM. So without doing anything, some parts of your programs might run faster. Why not use it? And the last point, as I mentioned already, is you can build native images, and native images work great with Docker. Who's using Docker? Who's using Kubernetes or OpenShift? So I think you see how this could be beneficial when you're using a native image, a native binary, instead of Java bytecode. In particular, we'll see that the ramp-up time for an application is virtually non-existent. So let's see how to use it. We will start with some code that most of you might find familiar. Who of you has used Nason or Rhino in the past? Okay. Then this might look somewhat familiar. What I have here is a snippet of Java code. Can you read this? Let's switch to presentation mode. No. What I'm doing here is I'm creating a context that's more or less the context in which the Gras language is executed. In this case, it's JS. So most samples I show are either Java to JS or JS to Java. Those are the two languages I'm most proficient in. But you can use other languages as well. Yeah. So you can, as I said already, you can use Ruby, R, Python. At the end of the talk, I will give you a link to a GitHub repository with some samples. Those are benchmark samples, so they are not the cleanest to learn, but they have examples how to load Python, Ruby, some C code. You can look into this if you like. In this case, we just give the script, the JavaScript you want to execute here as a string. Yeah, that's this part here. And those of you who wrote some code in Nason or Rhino might say, wait a minute, this looks awfully familiar. Well, on this level it does, but keep in mind, this is not booting up some JavaScript runtime within Java. We take this JavaScript code, or rather Graal takes the JavaScript code, transforms it to Java bytecode, and then executes this bytecode natively on the JVM. What we can do now is we go to the context, say get as the member of say hello, which is this function, and cast it to a unary operator, and store this in some variable of type unary operator. If this would be some class file or constant field, you can now use this snippet of Java code everywhere in your program. And it's hot compiled, it's bytecode, you get all the good stuff you already know from Java. Any questions so far? Who likes writing code as strings in other languages? Exactly, nobody does this. You don't have any support here, you don't have syntax highlighting, no auto-completion. So the next logical step is naturally don't write the code as string into your code, but outsource it to some source file and load the source file instead. The process is a little bit different. You don't tell the context, hey, this is from language JavaScript, but rather you create a source, which is your source file, and the source knows the language. Yeah. Here again, we see the interoperability. I don't have to use only JavaScript. I can mix up things. I could have one function written in JavaScript, another function in R, a third function in C or Bytecode, and they can all run on the same environment, in the same context. And now in this part you can use all your goodies. You can edit this file with IntelliJ or Visual Code or whatever editor you like. You have your syntax highlighting, you have your checking, linting, so you can use the power of your IDE. And just to show you that it's actually working, we can execute this code, and if I haven't broken anything, we should see, after some compilation, some hello JCON2019, this is JS speaking. Pretty good, isn't it? So, this is the part that looks similar to the ones of you who already have worked with Nashorn, but that's only one direction. GraalVM isn't limited to just using Java as the source language and then calling other languages. We can also say, no, my starting language is, for example, JavaScript. And I want to load, for example, some Java jar file and use this in my JavaScript. Yeah? In this example, I know that my target jar is lying under exactly this directory. I can load this. It will load this Java class. It's a simple user pojo with some name fields, some email fields, creation date, and we also have some factory methods. And when we load this jar file into our JS code, we can actually now use this Java class as if it were a class in JavaScript. Yeah? To show you that this is working, I have a terminal right here. I think that's the one without GraalVM. This is the one without, this is the one with GraalVM. Or maybe not. And we are in just to show you, if I now query which JS is used, you see this is a JS version provided by GraalVM. I'm not running this script through the ordinary JS. If I would try to, I would get some runtime exceptions since there are libraries used JS doesn't know. Also some mechanism JS doesn't know. Since I use interoperability, I have to use the JS version of GraalVM. And I wrote down the command to execute the script right here. You see already we have some parameters we normally don't pass along. In this part here, I am telling the GraalVM JS to run with JVM support. This is what allows me to load the JS code and run it and load other languages within them. So without these ---- JVM option, if I'm trying to run this, oh, looks I forgot to build. I'm just skipping tests now since there's quite some tests in the project and I know already the code is working, so we don't need them. So, cd. Oh, that's funny, there's a type error there. So Lucky Socks didn't work. I'm not able to show you this example, but what would normally happen is that this part here gets called from Java, and within this part we are able to create a native Java object and run it inside our JS script. So what you can also do is not only call this part from JavaScript, but I hope this is running. And yes, it is. What you're doing here is we create a user in Java. We then create our context. We will talk about this here in a minute. Now we load a JavaScript file. To be exact, we load this file here. Within this file, we have a function modify user. This means we are creating a user in Java, passing it along to JavaScript to modify it and observe the modification back in Java. So, in order to do this, we have to somehow transfer our user object, which we have created here, into the environment of JavaScript. This is what this command is for. We tell our context, hey, for the language JavaScript, please put this Java object into the context under this name. This first step to get this interoperability. The second step is we have to explicitly allow that JavaScript is able to access fields and methods within this class. Otherwise, if I remove this line here, the code won't work. And when I remember correctly, it won't work in a very interesting way. We won't see the modification actually. The code won't crash or anything. We just don't see that anything is modified. So we need our allow all access. When we now execute the code, I think we still don't see any changes. And this is because we set name and email here to janedoe and jane@doe.com. When we now look at the user object, the fields are set to private. Yeah? As you all know, JavaScript is typeless, and when I try to access a field that isn't there or is not present, JavaScript has no good semantics to express this. So what it does is, yeah, okay, there is some field I'm overriding something or hiding something actually, but it's a separate field in JavaScript. It cannot access the Java attribute, so it creates a new attribute which isn't visible from Java. When I now switch this to public, let's just switch the email, so we should now see that the name isn't changing, since it's still private, but the email will change. When we now execute our code here, we see, okay, the name hasn't changed, it's still John Doe, but the email has changed, Jane Doe and Jane Doe. I think I forgot to mention this, when we look where we are logging, the first logging takes place, I think inside this part. No, not exactly. The first logging takes place within the JavaScript. The parameter is coming in. Within JavaScript, the parameter is going out. And the third logging is what Java is seeing. So we see when the user is coming into JavaScript, it's as we expected. First name is John Doe, email is John Doe. JavaScript sees the same here. After modification, we have to change the email. And Java also sees the change. When you remember back, when this field is private, we will see that all outputs are the same, that all outputs show the output John Doe with email John Doe. So actually, even JavaScript is not able to see its own changes. Another call trick might be if you're writing clean code and you want to encapsulate everything, you would say, okay, I'm not using the fields directly. Let me use the getters and setters. Yeah? So we could write here instead of user.name, user.setName. And user.setEmail. And when you're looking back into a user class, we see setName and setEmail are set to private. So what output would you expect from JavaScript? Would you expect the name to change, or would you expect the name to stay the same? Raise your hand when you think the name will change. And who thinks that the name shouldn't change? Okay, interesting, interesting. Let's take a look. We actually get an exception. We don't have a modify user method, JavaScript is complaining, and that's all right. So let's switch it up. Let's set this method to public and this method to public. So who thinks that now everything should work as we have designed it? Okay. Let's run it again. Let's see. Exactly. So you see, even though JavaScript has not really a concept of this hiding of attributes as we have in Java, the properties we know from Java are still enforced. Yeah? So keep that in mind when you're trying to play around with your GraalVM implementation. You have some Java code that's nicely encapsulated, and you have everything reduced to minimal visibility, and things aren't working. If this is, then maybe you have to relax your visibility a little bit and be a little bit more generous to be able to access the parts of the code you want to access. Okay, so I would like to show you some other example of interoperability. This one isn't my own. It's actually from the official GraalVM demos. And what I have here is this a write file. It's a write file. I have a server, some node server. Yeah, here, Express. What I'm doing now is, first off, I get the Java type of bit integer. For Java, you have some special interoperability since Java is a base language. Everything gets compiled to, so you have a little bit more library support for all the for the base language. It's a little bit easier to handle. I can now just get the type of bit integer in JavaScript. Down here, I call the methods just as I know them from Java, say value of 10 power 100 and add big integer 43 and call to string on this. Yeah. But not only this, I can, what they're doing here is, okay, after this, call some R function, make some sample if else, if 1 is bigger than 2, which is obviously not true, then add some pipe symbols, and after this, call another R function, calculate some values, in this time it's some sine, cosine, whatever, we'll see it in a moment, and plot this. This is what I meant by choose your tool. Yeah? Writing this kind of code in Java is, well, not hard, but annoying. Java is not designed to handle matrices and 3D printing and plotting. R is. Here we have a pretty simple way to just express what we want, to make a 3D plot, and we can use it from JavaScript. Okay? So let's start up this example. Then I have to change directory. Oh, come on, come on. It's too early in the morning. Still wrong. Still wrong. Here we are. And we want to have Graal demos. Exactly. And I hope I can remember how to start this. Again, you see I'm starting node with --JVM. I'm telling it, hey, I want to run other languages with --polyglot. I'm loading other languages than Java. I'm telling Node, hey, I'm not only using Java, I'm using different languages as well. And --inspect will give me some link to debug my application. Yeah? So I will start the server without inspect first. It should boot up shortly. Exactly. Now let's access the web page. It's localhost 3000. And you notice already, okay, it's taking a little bit of time. In the background, GraalVM is loading the R script, compiling it back to bytecode in Java, and now we have our plot. Yeah? When we zoom in, we can see, maybe not, maybe, not really. This is the part we printed from Java through big integer. One, I think, 79 zeros, 403. This is a pipe we printed, the one empty pipe is printed through R, and this is our plot we generated through R as well. And you have seen there was some initial delay. Graal had to load the R script, had to compile it back to the bytecode. It was pretty slow, but when I now refresh the page, you see it's pretty fast. And since there's some random element, every time I push F5, you see the dots are jumping around a little bit, and it's pretty fast now. Initial connection, just like with lambdas in AWS or functions in Google Cloud, the initial start is a little bit slow, but after that, you have a pretty good performance. Okay, that's interesting, but you have seen already that I had the minus inspect. Who knows what inspect does? Okay, one person, it gives me some link to connect my Google DevTools through. So I can now access this link. Come on. This is my debugger, and now I want to open another window. I've set already a breakpoint here, directly in front of the R function. Now I access localhost 3000. Again, we notice the initial delay. But at some point, we are going to jump to the breakpoint, exactly now. And okay, we can see the stack. Can you read this? Yeah, no? A little bit? Okay. We have our stack trace here and everything is fine and nothing out of the ordinary. But what I can do now is I can set my breakpoint right inside this function, if I'm able to. Come on. I think I have to step into it once. Exactly. I just stepped into the R function. Here I can set my breakpoint, run through the breakpoint, and hopefully now I have the stack of my R calls. With my Google DevTools, I have connected to my Node.js server, which is running R. I have set up a breakpoint inside the R code and can now debug the R stack. So you have one tool to write your languages, and you have one debugger to debug the all. And in every context, you see exactly what you would expect in this one language to see. Pretty awesome, isn't it? Any questions so far? Yes? As I have shown in the beginning, Graal is coming with some runtimes. And I think it was this window here. And as you see, there is already a R runtime installed. Exactly. So Graal is coming with its own runtime. Asterisk, some languages are not installed from the get-go. For example, Python is not installed from the get-go. You see in this folder there's somewhere a GU file. Exactly. Right here. This GU is the Graal updater. So if you try to run a language and Graal is complaining, oh, I am unable to find this language, just run this GU file with, I think, whitespace install, whitespace language name, and Graal will fetch the language for you if it's present. Does this answer the question? Does it answer the question? Okay, and I think you had another question.
Oh yeah, I was just wondering, in the stack trace that you were showing, I only saw JavaScript area called. I was wondering if you could go down the stack with it and show us some R stack, if that's possible, or if all we see are JavaScript.
We are actually library calls, I'm not sure. You're right, that are actually the calls right here. I can try to step into, and we should see exactly. Is this what you're looking for? Yeah, exactly. So you can actually step into the native implementations of the language you're using, and you're seeing the stack of your native language. Other questions so far? Yes?
What about updating languages, or do you have to update GraalVM as a whole every time there is a new version of one of the supported languages? And just thinking about JavaScript and Node and...
Give me a short second. Good point. Actually, I'm not entirely sure. I think GraalVM, one specific version of GraalVM ships with one specific implementation for a language. What I would imagine in the future, you mentioned Node and JS. The iterations are pretty fast. I would imagine that you don't have one Node launcher but different Node launchers for different versions. And I would not expect them to update without updating GraalVM. Does this answer the question? No problem. Yes? In the middle? Yeah, exactly.
For debugging, is there also IDE support? Is producing some kind of source maps?
Not that I know of, but I will come back to this point at the end of the talk, since there is still a little bit lack of tool supporting. Okay. So, I have 5 minutes left, as I've seen. This is some benchmarking I did. The details are not important. What is important here? The red bars are the native runtime, for example, JS or Python or Oracle JDK. The blue ones are Graal. What you can see, for example, by Python is we have a pretty significant performance increase. For JavaScript, we are generally a little bit slower, and for OpenJDK, we are a little bit faster. Yeah? That's what I meant by you get some performance by just dropping in. Up until now, I have not yet spoken about native images. This is what I'm coming up now. The native image feature uses Substrate VM. Has anyone heard of Substrate? Okay, a few people. Substrate is a natively compiled VM that executes our Java code. So we still need at runtime features like garbage collection, and this is what Substrate VM provides us. But Substrate VM operates under a closed world assumption. That means we are not able to load classes at runtime. Yeah? This might, or you might now see why frameworks like Spring are not yet fully supported, since they are heavily dependent on this feature. There are ways around this, and you can make it work. Problem is, it's annoying and you don't want to do this. So this is coming back to the question you had about debugging. The ecosystem around Graal isn't quite there yet. Give it some time. Let developer experience GraalVM, let them have the time to implement the support, and I'm quite sure we'll see the tools. Compilation is pretty slow and pretty memory consuming. So 4 gigabytes of RAM is nothing for native compilation, and it can take up to 2 or 4 minutes. Yeah? But on the other hand, what you get is a natively compiled image that's pretty small, comparatively small, and you have a very low memory overhead when you're looking at the Java example. When you're using guest languages, you can still use them in the native language, in a native image, but the guest code does not get compiled. You're just loading the script code, executing it. This is not compiled to binary. And genau. What we can do is compile binaries with only static dependencies. That means your binary is completely self-contained. No references to other binaries. Important is that execution time is not at the core of the optimization here. Again, similar graph to the one I had before. The blue ones are GraalVM, the red ones are native images. We see in most instances the native image is slower than the run on GraalVM, since performance is not on the focus. What is on the focus, at the slide that was shown on Oracle Code 1, is startup time, and this is much faster. I want to show you one final demo. Again, this is not my demo. I've quote-unquote stolen it from somewhere else. That is a repository for a Spring Boot feature to implement Graal, and I've picked the thime leaf template here. Yeah, I have already compiled it in binary format. Spring feature, samples. We want the vanilla thime leaf. You can see here, this green thime leaf is my executable. this one right here. And I have a Docker file. Yeah? And what I'm going to do now is just say docker run. I want to run it on 8080 and I want to boot the sine leaf. It's running. So you saw already the boot up was pretty fast. Come on. Localhost 8080. Greetings. This is my native compiled image. And the last thing I want to show you is the Docker file I used. So I'm going to stop this and cut. It's a wrong window. I think I used this window. As you can see, can you read this? Yeah? We are using a Scratch container. We are using nothing. We are running a Scratch container, an 80 MB native file, and we have no dependency on nothing. That's the last thing I want to give you when you're going out of this talk. As I said already, tooling support is not quite there yet. Give it some time. Let the Spring people work, and I'm sure we'll see the tools. So, if you're interested, there will be a talk today from 2 to 2:45 about Quarkus. Quarkus is using GraalVM under the hood. Go check it out. For references, the slides I've presented, performance tests, as well as the code I've written, you can find on this GitHub link. And of course, I've said already, I have used some links from the Graal demo and the Spring Graal feature. And if you want to read more, there's a docs page on the Graal project. It's pretty good. Go check it out. And also there's a post about the top 10 things to do with GraalVM. Check it out if you like. I'm done, and are there any questions? Yes? There are garbage collectors. I think that Substrate is implementing G1, but I'm not entirely sure. But garbage collection is one of the main reasons why we have to use Substrate VM to handle the allocation. More questions? Then thank you again. I will be around. If you want to talk, just come along, and don't forget, #LuxuryTalks. Thank you.